To start the study of Statistics 1, we're going to go over things that you probably already learned in previous years. We're going over some statistical representation methods learned in previous years, and all of these that you can see here, one way or the other, you already studied them or solved exercises regarding them. We're talking about bar charts, pie charts, tally charts, pictograms, frequency tables, scatter diagrams, and histograms. At least as part of IGCSE or GCSE, these are all there. And we're going to continue focusing on at least some of these later on already in this chapter, particularly frequency tables, and these include group data and cumulative frequency tables, and histograms. We are also going to talk about something that is not here, but I'll talk about that in a bit. You also learned in previous years that whenever you have a bunch of data completely disorganized, I mean the data that is collected from and that has no order, this is called the raw data. There is need to organize it, to make sense of all that data. And in order for us to do that, there are two different types of statistical measures that we have to go over. First of all, the central tendency statistical measures, and then the measures of spread. What does this mean? As the name suggests, central tendency tries to give in a single value an idea of what the raw data encompasses, namely by trying to find its center point. And the spread will try to give you an idea of, as the name suggests, how spread apart the raw data is in relation to this central tendency mark. All right? In relation to the central tendency, you learn all these three: the mode, the median, and the mean. The mode, as you might remember, is the most or the more recurrent value. The median is just the middle value, and the mean is what we usually call the average. As for the spread, if I'm not mistaken, the only one that you've learned, the only measure of spread that you learn is the range. The range is basically just the difference between the maximum value that you have on the raw data and the minimum value that you have on that data. As mentioned, the data is collected with no clear order. You just go and collect the data with whatever order you will have, and then you have to organize it. To do that, you have to use one of these. Which one you'll use depends on the data that you are collecting. So you have to think of these as tools, and like any tool, you pick the one that best serves the purpose. So it will depend on what you are studying. And once you have the raw data organized, things like outliers are much more visible. What are outliers? Outliers are values that significantly differs from all the others. If you have such values, you should inspect them, try to figure out if these pieces of data were collected because of some flaw on the process by which you collected the data, or if not. If they are caused by a flaw, they should be just scrapped from the raw data, and you should work with everything else. Otherwise, after inspection, if you see that the data is true, so you should keep it there anyway. The range we already talked about. The mode and the modal group is something that you can get also from data analysis, particularly if you do one of these. All right. If you have a frequency table, the modal group is very, very easy to detect. It's just the bar that is taller, right? It may happen that you have two regions where you have two tall bars about the same size, in which case you would say that this is a bimodal situation. You have two modal groups. Sometimes if you write the graph like this, or even with bar graphs, you can say if there is a skew or not. If all the data is organized on a central value and it is equally distributed to both sides of that central value, you say that there is no skew. If the central value or the highest value is pushed to the left, you say that there is a positive skew. If it is pushed to the right, you say that there is a negative skew. You also talked most definitely about stem and leaf diagrams. If not, I'm going over them again with this example. Imagine that you have 20 competitors participating in a ski competition. The time in seconds each one takes to complete the ski course is given, and then you have here a bunch of data. As you can see, this is completely has no organization whatsoever. I just put it in the same order as it was collected. All right. So it's very hard to make any sense of this. So we have to figure out a way to present it in a way that makes sense just at a glance, just by looking at it. And one of these ways is a stem and leaf diagram. What is it? And how could you organize this in a stem and leaf diagram? Well, basically, this is it. If you count, you have a total of 20 data points, basically corresponding in this case to the number of participants, 20. And then you have something like this. And what does this mean? You have here the scale. A 5, a line, and a 1 represents what? Represents 51 seconds. So, knowing this, you can put here all the values that are within the 50 second range, on the 60-second range, 70 and 80-second range. And the reason why this is called stem and leaf diagram is that you have here 4 different stems, each one containing its own branch, and each value that you have on each branch is a leaf, the individual number. All right? If you see values that look like outliers, you can put them outside of the stem and leaf diagram, such as over here. You see that most of them are within the 50 up to the 80 seconds range. So a 19 and a 209 is probably an outlier. So they should be inspected, and you write them outside so that you can look at them straight away. All right. What else there is there to talk about this? The model class is particularly visible in a stem and leaf diagram. Is the branch that is longer. So over here, this would be the modal class. This is an unsorted stem and leaf diagram. You can do a sorted stem and leaf diagram. Why is it unsorted? The numbers are completely disorganized. So I just put them here in the same order that I had before. But I can rewrite it, the whole thing, like this. And this would be a sorted stem and leaf diagram. They are already organized. And here is much, once they are organized, figuring out what the modal time in this case would be, it's simpler, all right? Because here you have all these ones over here, means that you have 51, 51, 51, 3 times. This is the value that occurred more times. So it is the modal time. This is the mode. Imagine that you want now to compare 2 data sets. We may use back-to-back stem and leaf diagrams. These are constructed by adding branches to the left-hand side of the stem. You're going to see later on one of the exercises, you will have one of these. But basically, you have what you see here to the left, you'll have another line, and you see a new bunch of data. What you see here to the right, you'll have here a line, and you would write the same type of data here to the left. And it's easy to compare these 2 data sets at a glance as well.